Hello student, again we are here for the discussion of another concentration term, mole fraction. It is a very important, and here we will discuss some important concepts of mole fraction, and also we discuss how we calculate the number of moles of a solute or a solvent. First of all, mole fraction. What is mole fraction and how can we represent the mole fraction? Mole fraction can be represented by the symbol small x, and it can be calculated by using the following formula. Number of moles of one component means the mole fraction can be calculated by using this formula. Number of moles of one component is compared with the total number of moles of the solution. Means the total number of moles of the solution will be the number of moles of the solute and number of moles of the solvent. And here the number of moles of one component means it may be the number of moles of the solute, or it may be the number of moles of the solvent. Okay. The mole fraction can be calculated by using the formula number of moles of one component and compared with the total number of moles of the solution. Okay. When a solution is made by the component A and B, here we consider a solution, and this solution can be made by the generally we study the binary solution in this chapter. In the solution chapter we have to study the binary solution, means the solution which is made by the combination of two components, and here we consider an example of binary solution, and this binary solution is made by the combination of component A and component B. In the same way, when the solution is made by the component A and B, the mole fraction of each component can be given as, means the mole fraction of A and mole fraction of B can be given as mole fraction of component A can be calculated number of moles of A. Okay, number of moles of A divided by the number of moles of A plus number of moles of B. Okay, again the mole fraction of a component A can be calculated by using the formula number of moles of A is compared with the total number of moles of the solution, means the number of moles of A plus number of moles of B. Okay. This can be written as a XA. XA means mole fraction of A component and is equals to the number of mole. मतलब जो यहाँ Na लिखा हुआ है, here we write the Na. Na represent the number of moles of the A, and Na and plus Nb is the total number of moles of the solution. Okay. Same way, when we consider a mole fraction of component B, it can be calculated by the formula number of moles of B is compared with the total number of moles of the solution, means the number of moles of B plus number of moles of A. Okay. In the same way, XB represent the mole fraction of a component B and equals to the NB upon Na plus NB. Okay. Here is the NB is a number of moles of the component B, and Na and NB is a number of moles of the component A and B. Here it is a total number of moles of the solution. Okay. The mole fraction, how can we calculate the number of moles of each component? The number of moles of each component can be calculated by using the formula mass of the component divided by the molar mass of the component. Means the mass of the component means the mass of the component A and B. Okay, the mass of the component A and B means the given mass of the component divided by its molar mass of the component. मतलब अगर आपके पास जो भी component present है, A का अपना एक अलग given mass होगा, उसी तरीके से B का भी अपना एक mass होगा, और उसके mass को हम compare कर देते हैं किसके, उसी के molar mass से. अगर हमको component के मतलब अगर हमारे पास number of moles of the each component, अगर हमें component A का number of moles निकालना है तो हम उसका given mass लेंगे, मतलब जितना mass उस solution में present होगा, और उसको compare किससे करेंगे, उसके मोलर मास से कंपेयर करेंगे. ठीक है. सेम कंडीशन में जैसे अगर हमको B मिलेगा तो हम भी क्या करेंगे, उसकी जैसे सेम यहाँ पे है Na, नंबर ऑफ मोल्स ऑफ A इज इक्वल्स टू द गिवन मास ऑफ द कंपोनेंट A डिवाइड बाय द मोलर मास ऑफ द कंपोनेंट A. मींस जो मास उसका दिया हुआ है उसको हम लोग किससे डिवाइड करेंगे, उसके मोलर मास से डिवाइड करेंगे. सेम कंडीशन में अगर मेरे पास Nb होगा, ठीक है, तो Nb को भी हम कैसे निकालते हैं, गिवन मास ऑफ द कंपोनेंट B डिवाइडेड बाय इट्स मोलर मास ऑफ द कंपोनेंट B. ओके. There is an important relationship between the mole fraction of the component present in a given solution, generally the components, the number of components is present in a solution, their mole fraction, when we add their mole fraction, it is always equals to the 1. And if we consider a binary solution, means this binary solution is made by the combination of two components A and B. Therefore the mole fraction of this the addition of the mole fraction of these components is equals to XA, means the mole fraction of the component A plus XB. Mole fraction of the component B is always equals to the 1. Okay, it is always equals to the 1. It is a condition for the binary solution. In the case of the ternary solution, there will be a 3 components, means A, B and another will be a C. Therefore their components, if we add the mole fraction of their components, means XA plus XB plus XC, it is always equals to the it is always equals to the 1. Okay, the important thing is when we consider very important thing is when we add the mole fraction of the component present in the given solution, it is always equals to the 1. Okay, from this relation we can able to calculate the mole fraction of another component when we mole fraction of another component by knowing the mole fraction of by knowing the value of mole fraction of the one component. Same condition when we apply this relation, here we got a two types of relation here. From this relation we can able to calculate the mole fraction of B by knowing the mole fraction of the component A, 1 minus XA, and if we know the mole fraction of the component B, we can able to calculate the mole fraction of a component A by using this relation XA equals to 1 minus XB. Okay, here it is an important concept for the mole fraction of a solution. Okay, thank you.